right now we're on our keynote, API3 Decentralized APIs for the Decentralized Web. And we're joined by our speaker, co-founder API3 and data scientist API3, Sasa Melic. Well, Sasa is a researcher in the blockchain space. She's a co-founder and developer at the API3 as well as a data scientist at the Kotlet Networks. Previously, she was somebody who was in the software engineering with both small startups and large tech companies, data science in venture capital, research, computational linguistics, cognitive science, and teaching computer science, data science in both academia and industry. Thank you so much for joining us, Sasha, and being a part of the World Blockchain Summit Global Edition. We really value your time. Over to you.
Thank you so much for having me.
Pleasure.
So I should just start, right?
Yes, absolutely. We're just waiting for you to take it forward. Thank you, Sasha.
I'm Sasha. I work for API3. I'm one of the white paper authors. I also work as a developer on the team. And I'll be discussing, so I planned for a 15-minute presentation, but it looks like it's 20. So I might be a little bit short, but I won't go over time. And so starting off with what is an API, this is actually surprisingly difficult to answer, which is kind of ironic because it's something so ubiquitous in computer software. So actually, I won't discuss this fully because it would take like a whole nother presentation, but I did write a Medium post about it. And I ended up having to do a little research in software history to actually answer properly what an API is. But I'd recommend you reading the Medium post, but to give you kind of a standard uninteresting answer, perhaps, an API is the communication layer between software abstractions. And more specifically, since API is used so ubiquitously, we'll be talking specifically about web APIs, which are interfaces that connect publicly exposed endpoints of a network. And APIs, the definition isn't so much interesting. It's more interesting what they allow software engineers to do. So nowadays you can build incredibly complex and capable applications, just basically gluing APIs together. Like you can access cloud computing, cloud storage via APIs. You can access data through Twitter. You can even interface with certain AI algorithms and machine learning algorithms simply through APIs. So arguably APIs have allowed us to make web applications at a speed and at a rate that we've never been able to make them before. So what they allow is probably more interesting than just the basic definition. So how does this relate to blockchain? Because that's what we're discussing here. So a blockchain allows us, it's so powerful because it allows us to come to consensus. It allows us to come to consensus in a distributed manner. So this is powerful and limiting because every single node in the network has to come to an agreement. So for example, with Ethereum, we have this giant global computer, and anytime we want to do a transaction and update this global state, every single node in the network has to agree to update the state of the network. So again, this is very powerful because we can have a decentralized consensus mechanism, but it's limiting because we cannot access the outside world. So the nodes in the network can only come to consensus on the data that exists on the network. So by default, this is just simple memory updates. So what this really means is that by default, what we can do on the blockchain is just send transactions to one another. And what this really means is crypto transactions. So in order to make the kind of applications that I'm guessing you guys have been discussing, things like insurance, things like supply chain management, so the decentralized finance applications we've been seeing really blowing up in the crypto space, all of these things need data. So DeFi, at the very least, you need price data. So that data isn't in the blockchain. Nodes don't actually know what the price of Ethereum is, Ether. And let's say you want to make insurance products, you need, let's say travel insurance or weather insurance, you need to have travel data, you need to have weather data. And these are all things that are accessible via APIs, but APIs don't naturally connect to the blockchain, because another way of putting it is the blockchain prevents any kind of central point of failure because it's distributed. But once you start trying to access data outside of the blockchain, you now have a central point of failure because you're trying to access data from a single source. I hope that makes sense. So that's kind of a roundabout way of getting at what the API connectivity problem is. The blockchain doesn't natively connect to anything outside in the digital world. And what that means practically is like you can't really connect to an API on the blockchain, and any interesting application requires the kind of data that is offered by APIs. So this, again, I don't know how technical my audience is, but this has already been discussed in the blockchain space, but it's been called the Oracle problem. And the way that it's been phrased up until now is, we need an oracle, this perfect agent that lives in between the blockchain and the real world and can give us perfect information, because the blockchain, natively doesn't have information about the outside world. However, if you're familiar with the Oracle problem, it's a three-body problem. So you have a data source, an oracle that transmits the data, and you have an on-chain data consumer. So that's a smart contract, a decentralized application. And these existing solutions that exist to solve the Oracle problem, they all model their ecosystem as being solely composed of oracles and data consumers, but they ignore where the data originates from. And this will probably make more sense in my next slide. Yeah, so this is the architecture for current Oracle solutions to the Oracle problem. So you'll have multiple oracles, these third-party oracles that get information from somewhere. So let's say they're trying to get the price of ETH. They get their information from somewhere, transmit it onto an on-chain aggregator that takes the mean or median. So this is the architecture of existing solutions. And it might make more sense when I compare it to API3 solution. So on the left is our existing solutions to the Oracle problem, or the off-chain data problem, however you want to call it. And right is what we are building with API3. So we're building what we call first-party oracles. So we're not ignoring the data source. We recognize that people need data from APIs, and it makes much more sense to have API providers provide that data directly than having these third parties. So that's what I circled here. These are, in the existing solution, these are what we call third-party oracles that get data from some unknown source and transmit it onto the blockchain. And I'll discuss why this is an issue in the next slide. So these third-party oracles that get data from some unknown API, the issue with this is, or there's multiple issues. So this creates an entirely new attack surface area. So this adds more vulnerability to the blockchain. And this is unfortunate because the blockchain is supposed to be something that is almost, I'm not going to say indestructible, but it's supposed to be close to that because you don't have any central points of failure. You have all these distributed nodes coming to consensus. You also have something that we call a middleman tax, and we get into much more detail in our white paper about this, but this is, there is a large financial incentive to provide incorrect data to smart contracts. That's because, think about, for example, a financial derivative. If you're a party in a financial derivative, you providing data, incorrect data, that means a payout for you. There's a very, very large financial incentive if you're a party in a smart contract that has some sort of a payout to provide faulty data. So to prevent this, these existing solutions, you have to basically, without getting into too many details, you have to pay these middlemen a lot of money to incentivize them to not provide faulty data. You also have expensive and ineffective redundancy. So redundancy is usually a good thing on the blockchain because it's what allows distributed consensus. But here, what you have is you'll have multiple these are like existing data feeds that are used for decentralized finance. You'll actually see this. You'll get multiple third-party oracles getting data from the same source. So it's not really adding any kind of decentralization. It's just adding costs and security risks. And you also have a lack of transparency. So you'll see with some existing data feeds used in the crypto space, they'll say, you know, we have like 10, 20 oracles, but they're really getting their data because you'll have like 3, 4 oracles getting data from the same source. So it's not as decentralized as it appears when you're not transparent about where the data is coming from and which APIs you're using. Again, I hope that makes sense. So just to, after that explanation, just showing this slide again to give you a sense of our solution on the right, having the data sources directly provide data to the blockchain in a distributed manner. So getting multiple APIs that provide similar data to provide data to the blockchain versus having kind of no-name middlemen get data from who knows where and transmitting that to the blockchain. So at this point, at this point, maybe you're wondering, you know, why don't we currently have solutions where API providers run their own Oracle nodes and transmit data? So, you know, like, why can't these third-party oracles in fact be first-party oracles? Or you might be wondering, you know, why would a traditional API provider, oh, sorry, I heard some noise. Or you might be wondering, why would a traditional API provider even operate one of these Oracle nodes and even participate in the blockchain space? Well, we actually go through that very, very long-windedly in the white paper, but I can't get into all those details now. But I will say one main feature of our solution is something called Airnode. And this is just a screenshot from our GitHub, which is public if you want to check it out. Airnode is a fully serverless Oracle node that is designed specifically for API providers to operate their own oracles. So this is serverless just means that it can be deployed on multiple cloud platforms, and it's stateless. It doesn't need to be maintained by anyone. This is something that can be deployed in 3 minutes and not have to be maintained in any way. So this is basically just an additional revenue stream for API providers with little to no cost or effort on their part. So this is one of the kind of main architectural features of our solutions to get API providers to be the oracles that provide data to the blockchain. I actually don't know how much time. I think I'm already 15 minutes in. So I had prepared for a 15-minute presentation, but this is an overview of our whole solution. So I've been mainly focusing on why first-party oracles are better than third-party oracles and how we address creating a first-party oracle that API providers actually want to use. But our solution is more complex than that. So we have insurance for data feeds, because we realize that you can't, when you're dealing with real world data and not just kind of the discrete data that you deal with on the blockchain, there's always going to be issues that come up, and you just simply can't prevent any possible data fault from occurring. So what we have in place is insurance for data feeds. And we also have, we actually write and talk a lot about this on our Medium, about the importance of decentralized governance for blockchain protocols. Because, you know, if you're building a decentralized protocol, you should probably be governing the construction and engineering of that in a decentralized manner as well. So I can't, unfortunately, in a 15 minutes, I can't get into the whole overview and every single feature of our solution. But first-party oracles is really a central feature, but there's other things that play into all of this. And that's why I included this on the slide. And maybe some people will have questions and I'll be able to get into more details about this. Yeah, so that's my presentation. I had prepared for a 15-minute presentation, so I might be a little bit short, but I'm very willing to answer questions. But yeah, this is our website, api3.org, and there you can see all of our links to our social media, where we've been pumping out, like, I'd say really good Medium posts, Medium articles, like weekly. We're pretty active on Twitter. yeah, so the website is pretty much the central source for where you can get more information about us.
Sure. Thank you so much, Sasha. Well, in interest of time, we'd like to still take one question for sure, because there have been a lot of questions coming in from the audience.
Sure.
The first question, and the only question, honestly, I can take right now in interest of time is, firstly, persons saying congratulations on the funding round. Also, could you elaborate how API3 solutions are different from Chainlink, is the question which has come in.
So how much time do I have to answer the question, just so I know?
2 to 3 minutes on top,
okay,
if that's
sure,
okay.
Sure. Yeah, that's a good question. So I'm glad that there's people in the audience that are familiar with this space, because I don't know how many people would be familiar with the Oracle problem. So one of the thing that I focused on here in this short presentation was first-party oracles versus third-party oracles. So Chainlink is a third-party oracle solution. So in their current data feeds, or at least in the current manifestation of their protocol, the current data feeds, you'll have something like 20 to 30 nodes, and they'll show this, but you don't actually know where any of those nodes get their data from. And it actually required a lot of investigation on my part by kind of like scanning the network and asking people. And it turns out, you'll have 3, 4, 5 oracles getting data from the same API, but none of this is transparent or public because of kind of the reasons I mentioned before, the way the third-party oracle solution is constructed. So this adds a lot of cost, right? Because you're actually getting data from like 5 or 6 price APIs, for example, but you have 20 to 30 nodes transmitting this information. So this doesn't actually make anything more decentralized. It just adds costs. It adds security risks. So I guess the main difference is this whole where we're focusing on a first-party Oracle solution. So getting API providers to provide data directly, and that way you actually know, if you're looking at a data feed, where that data is coming from. Is it coming from CoinGecko? Is it coming from CoinMarketCap? How many exchanges do they get their data from? How is that data aggregated? How do they remove things like volume inflation by exchanges? So the main difference, I'd say, is our focus on first-party oracles. But there's a lot of other differences. Like we have a DAO, so all decisions are made publicly, openly, and voted on. Chainlink is a private company. We also have, we're also building insurance for our data feeds. That's something that you would have to get from another party if you were to use Chainlink data feeds. So those are just some, it is a very different structure, but those are, I think, the main points of difference.
Sure. Thank you so much, Sasha, for joining us and being a part of the World Blockchain Summit Global Edition. Thank you once again for your valuable time. And ladies and gentlemen, API3.org is the website which you got to refer. And we'll see you on the other side in just about a few minutes. Thank you all for joining us. Thank you, Sasha.
Thank you.